Assalamualaikum warahmatullahi wabarakatuh. We are from group 4. With me, Aziz Aiman. And my 4 other teammates, Ang Yijian, Nurul Ain Syuhada, Sarah Xia Cui Hui, and Dayang Nurdina. And our team gonna present about confined flow, an example of confined flow. And what is confined flow? If the inlet is designated as 1 and the outlet as 2, it follows that M1 equal to M2. Thus, conservation of mass require this equation. If the density remain constant, then P1 will equal to P2. P here equal to pressure, and the above become the quantity equation for incompressible flow, as to show in the figure.
Now, let's take a look at an example of confined flows. We have a flow originating from a tank driven by gravity. In this particular question, we are given the diameter of the stream of refreshing beverage as 0.01 meters and the diameter of the cooler as 0.2 meters. Our task is to determine the flow rate Q from the bottle into the cooler in order to maintain a constant depth of beverage in the cooler at H equals to 0.2 meters. To begin, we write down the Bernoulli equation and label it as equation 1. We assume that P1 and P2 are equal to 0. Z1 is equal to H and Z2 is equal to 0. Next, we will get the second equation by substitute this value into the equation 1 and note that H is a constant. According to equation 3.19, also known as the continuity equation, A1V1 is equal to A2V2. Since the area A is equal to pi d squared over 4, we can get the equation pi over 4 d squared V1 equals pi over 4 d squared V2 from the continuity equation for incompressible flow. Hence, V1 equals small d over capital D squared V2, and this is labeled as equation 3. By combining equation 1 and 3, we obtain a formula to calculate the velocity V2, which turns out to be 1.98 meters per second. Finally, we substitute the value of V2 into Q equals 82V2, resulting in the final answer of 1.56 times 10 to the power of negative 4 cubic meters per second. I hope my explanation has been clear enough, and that's all from us. Thank you.